Hello everyone and welcome to today's workshop. So as you know, we will have the second day of this WEkEO for atmosphere monitoring, and this is a Copernicus WEkEO service workshop. And today we will have the practical session. So as you know, 2 days ago, we gave you an introduction to the Copernicus service, what sort of data you can find, what we provide in terms of global data, and we also provided you with some examples on how you can use the data on atmosphere monitoring. So today we will have the practical session, and we will show you how you can visualize the data sets and how you can apply it to a case study. And before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, don't forget to join the audio, obviously, on the left bottom side of your screen, and do not use the chat that you see on your right-hand side for the questions. You can use it for small talk, to say hello to us, or discuss with each other. But if you have a more technical question, or if you have any other question, you can use the Q&A section on the website. So you will find it on the top bar of your page. We will also put the link in the chat if necessary. And yeah, you will find the Q&A button with the Q&A section, and that's where you can ask our speakers your questions today. You will also find the survey about the workshop that you can answer at any time. And yeah, and okay, so for the agenda of today, we will have one demonstration and 3 tutorials. So the first demonstration will be of the WEkEO Viewer. So it will be done by Alexandre Borez from Mercator Ocean. And then we will have the 3 tutorials presentation. So we will start with the Jupyter Notebook tutorial by Alexandre Merin from Noveltis. Then we will have the QGIS tutorial by Daria Andrievska, also from Noveltis. And finally, we will end with the RStudio tutorial by Simon Millet, also from Noveltis. So we hope you had time to take a look at the tutorials we made available on the website a few days ago. And yeah, we hope you have some questions for the speaker today. And yeah, so now we will start with the WEkEO Viewer demonstration. So Alexandre, you can start showing your screen whenever you're ready. Welcome.
Yeah, hello everyone. So, hello everyone. Today we are going to take a look at the WEkEO Data Viewer. We will show you how to search for the data you're interested in. We will see how to visualize and download your data. And we will also go through the interface and tools so you can get more comfortable using the platform. So let's meet on the WEkEO homepage that you can find at the URL wekeo.copernicus.eu. The old one, wekeo.eu, still work, but redirect to this new homepage. Just before, let me show you how to create your WEkEO account. So you can click on sign in to access the sign in page. And from there, you can click on create your account. Here you can fill in the form. A WEkEO account is totally free. And your WEkEO account will let you access different tools and allow you to download WEkEO data. Once your account will be created, you will receive email verification. And once it's done, you can go back to the sign-in page and connect to your WEkEO account. Once you're connected, you will land on the new dashboard, My WEkEO. From there, you can easily navigate through different WEkEO tools. So the first one, the WEkEO Data Viewer, which we will explore more in details today. Then the WEkEO Data Catalog, where all available products are referenced. Then the WEkEO Workspace, which provides you with a private Jupyter Hub environment. It comes with pre-installed support for Python, R, and Julia. Many useful libraries are already included, such as the HDI API that be useful to download the WEkEO data, as well as libraries for data manipulation and analysis. And the last one, WEkEO Drive, to store and share data up to 8 GB of data. So now let's meet and take a closer look at the WEkEO Data Viewer. As we are on the new version of the WEkEO site, we have now the Lite Data Viewer. This viewer is aimed to be used by beginners to start explore data. On the left, you have access to the 5 Copernicus services, and for each of them, you can display easily on the map their main projects. For example, for marine, you can display the temperature. For Copernicus land, the tree cover, Copernicus atmosphere, ozone, climate change, wind speed, and Sentinel, the normalized difference vegetation index. If you go back on temperature, you can see at the top the name of the variable, seawater potential temperature, with the unit, degrees. Just above, you have the date of the data display. You can change the date at the bottom with the time bar. So you can click on the time bar to change the date. Quick tip, you can zoom in with your mouse scroll to get more precise to choose your date. The data will update automatically. On the right, you have the color bar. So you can modify some parameters like the opacity of the layer. You can change the color to get something with more contrast. And you can change the min and max value. For example, if you want to focus on higher temperature, you can set the min value to 20 and see only values in this interval. Then you have the equatorial tool to change the projection from equatorial to polar north or polar south. So let's go back to equatorial. It depends on the dataset, but for marine, you can change the depth if you want to see temperature at different depth. So if we go to 2000, sorry, the viewer don't update too quickly. Waiting for Taisia, it's loading. So let's talk about the other button, the setting button to display or not the base map. You can see in the background that it's going white. So you can remove the base map, remove the coastline and reference features, change the length from kilometers to miles. Same for area. And you have all the credits. Then you can talk to an expert with this dedicated button. From there, you can browse and search articles from our help center. So you can click here and browse all the collections. So if you are getting started, I invite you to browse this collection and see how you can create account like we see before, etc. And if you still have question, you can ask question to us. You will first talk to Neo, our AI agent. And if you are not satisfied with his answer, you can still talk to us, the WEkEO user support. So if it's not update, we will switch to the expert data viewer. So you can switch at the top right like this. If it's the first time you meet this page, you will have 2 products already display, the normalized difference vegetation index and the seawater salinity. So you can zoom in and zoom out to see more details about the layers display. If you want to search for a specific data, you can click on the plus button next to layers to open the WEkEO catalog. So on the right, you have all the datasets available, so more than 400. You have the name of the dataset here in bold. Then you have the time extent of the dataset, a quick description, and then the thumbnails to have a quick overview of what the data looks like. You have this icon, the /i icon, that indicate that this dataset cannot be viewable on the viewer. So you still can download it, but you will not be able to see it in the viewer. Then the star to add the dataset to your favorites. On the left, you have all the filters. First is to search with keywords. Then you can choose to see the viewable dataset, choose the Copernicus service, the platform, the area. You have many tags. And today we will choose a viewable dataset, which is Copernicus atmosphere dataset. Here we will choose the CAMS Global Reanalysis dataset. So we will click on details to see more information about this dataset. So we will find the name of the dataset, the temporal extent, latitude, longitude extent, the button to add it to the map. It depends on the dataset, but you can have use cases related to it. Then you have the abstract with many information. So I invite you to see these details if you're not sure which dataset you want to choose. Then in the classification section, you have the dataset ID. The dataset ID is important because this is the best way for us to identify which dataset you're using. So if you want to share, for example, with the user support, some question or issues with your download, I invite you to share the dataset ID, but we will see later another way to do this. The Copernicus service, so atmosphere, area, time, resources with the metadata. And then for some of you who are interested in, you have the WMS, WMTS section where you can copy the link to the WMTS of the dataset to get access to and create standard web mapping service. So now let's add this dataset to the viewer. So we have to choose the variable we want to display. Today we will choose total column carbon monoxide. So we click on Add to Map, and this add the layer to the viewer. So if you want to only display this layer, we will hide the other by clicking on the eye icon. So there we have the name of the layer, the unit, the time at which the variables are displayed on the map. So we can change with the time bar at the bottom. Then we have the color bar and many icons. So the first one is to subset and download data. So we will see it right after. The information button to get back to the information page. The layer button to change the variable we want to display on the map. So we can change from here. And then we have the parameter button to change the opacity. This can be useful if you want to compare two layers at once. So you can decrease the opacity and compare. And also you can change the color of the data. At the bottom right, we have tools. So the equatorial button to change the projection. The point to draw a point on the map and display a quick graph of the variable at this point. Quick tip: you can click on escape on your keyboard to escape the tool like this. Then we have the measure button to draw and calculate the distance between 2 points. And the most important, the set AOI tool to draw a bounding box on the map. So this is very useful to subset your data because once you draw an AOI on the map, an area of interest, you can use it in the subset parameters to download data only in this bounding box. So keep that in mind. So we will draw a bounding box here in France to subset after. Then we have the help button to open the widget to browse articles of the WEkEO Help Center and ask us a question if you have. And the setting button to like we see before, show not the base map, cost line, change units, see the credits. And now we will see how to download and subset data. If you are not logging in, you will need to have to do it. So you need to create a WEkEO account. It's free. It's can be created in the home page with the login button. And now we see all the parameters we can define. You will see that only fields marked with asterisks are mandatory. So not all of them are mandatory. Keep that in mind because it's often the case where people define all the parameters and the data they request have no results because they define the request too much. It's more precise and you avoid all the results. So I invite you to only define the mandatory parameters to have results in the first time. And if you want after to more select and be precise, add parameters. So today we will choose the carbon variable, total current carbon. And so these parameters are not mandatory. We will download all the August month. We can copy from layer the date. For example, if I want to choose the date at the bottom with the time bar, I can. And I copy from layer it, and it will appear right here. But for today, I don't want to do this. So August 1 to August 31. The time we will choose to select all. Data format grid. And there, you can choose to define your bounding box manually or copy the area of interest from the map, so this one, and this will enter all the coordinates automatically. So we will normally download data only in this bounding box. Then don't forget to agree to the license. And we have this quick link to the Help Center. If you are lost or if you don't know what are the next steps, I invite you to click to the link to access the how to download WEkEO data article, which I invite you to browse if you don't know what to do next. And if you still have questions, you can contact us, sure. Then we have the show API request. This is the request you have defined and all the parameters that are inside. The API request is very useful first for using the HDI API, so the Harmonized Data Access API client. I invite you to create your request on the WEkEO Viewer to get a valid request, so more precise and more valid than if you do it manually. And the HDI API is useful if you want to automate requests. So for example, if you want to download many requests by changing, for example, the dates 7 days by 7 days, or I don't know if what you want to download, but if you have many requests to made, I invite you to use it. And also if you have requests that have many results, with the HDI you can download them all at once with one command, but in the viewer you will have to click on each of results to download them one by one. I lost all my variables. Let me do them quickly. Sorry. Grip my bounding box. So yeah, yeah, the HDI API is useful if you have many results to download, and if in the viewer you will see that you will have to download them one by one. So for this, the HDI API can be useful, and also the API requests can be shared to the WEkEO user support if you have issues or questions. You don't know why your requests don't have results. You can copy and share it via the chat. so we can see more in details what you was trying to do, and we can reproduce your issue on our site. So let's now request data. At the bottom right, you can see that your request sent successfully. And the next step here is to click on the Jobs tab here, where you have all the jobs you have made. So here is the job you have done today with the date and the hour you have made. You can see that the job is completed. You can click here to display the API request. So this can be useful if you don't remember which request it is. You can quickly check what the parameters you have put for this job. And then you have the folder icon to see all the results. So here you have only one results. And to download it, you will need to order it in the first time. And then you will be able to download it in local on your computer in the file, the repertoire you want. So this can take a few seconds. And all the previous jobs can be deleted, for example, and you can browse all of them. So if it takes too much time, I will switch to another thing. Here you can, at the top right, access the Help Center. So I want you to browse the Help Center here instead of the widget, because you will have a better interface. So you click on Visit our Help Center, and from there you can see all the collections. And for example, if you want to know how to use the HDA API, I invite you to read this article, what is the HDA API, and how to use it, if it's in Python or in R. And the job is still running, but I have an error. So not for today, but it's just a download icon to download the data on your computer. And that's it. If you have any questions, or not today, but when you will try to use the viewer, don't hesitate to ask a question via the widget, and we'll be glad to answer all of them. Thank you very much.
Thank you, Alexandre, for your presentation. So we'll go to the question now.
Sure.
And okay. So, yeah, we lost your camera while you were speaking, but
yeah, I see that.
it's not that bad. We can still hear you, so no worries. So the first question being, is there a plan to include more data for visualization, especially for the atmosphere and climate data, for the data that we cannot visualize at the moment?
Yeah, this is a discussion that will need to be taken between the provider and our technical team to see what the needs to display data. But yeah, in the future, all data will be available to be displayed on the viewer. I wish.
Thanks. So this question, so asking if it's possible to zoom on the date with the timeline bar.
Yeah, sure.
And there is a timeline bar, and you can also choose the date directly when you want to download the product, if I'm not mistaken.
I don't get the last sentence. Let me show you if I don't already do. Yeah, you can zoom in the time bar, get a precise date, and yeah, choose the date you want.
Yeah. Okay, thanks. The next question. Can we use shapefile to download data?
No, you can't get a precise thing more than bounding box. You can only download via bounding box rectangles and not a shapefile.
Okay, maybe later, but not for
Yeah.
now. Okay, thanks. So this question is in two parts. So what are the maximum and minimum dimensions that can be used in the layers section when I'm adding a layer? Are there any specific values for these dimensions, or are they defined by default?
I'm not sure what we're talking about dimensions.
Maybe if we want to have like, I don't know, two parameters in the viewer, can we have it like just twice on the surface, or can we have it on like surface and 10 meters above the ground? Or
Oh, yeah. For marine data, you can choose the depth parameters to display data at the depth you want. It depends on the dataset and the dimensions that are available for the dataset.
okay.
Yeah.
Okay, so to be checked on the product information then.
Yeah.
Okay, thanks. This question, so do we have to be connected to be able to get products? So
Yeah, that's right. You need to create a WEkEO account. It's free. It's just a form to complete, and you will need to sign in before downloading and access the products.
okay, and can you go over the WEkEO Viewer without being connected, or do you still have to be
Yeah.
connected? Yeah, okay.
No, you can browse the WEkEO catalog, add layers, view variables. It's just when you click on download and subset that you will need to be logged in.
Okay, thanks. Okay, for this one. How are the datasets served to the front end? What type of server API is used for WEkEO?
That's too specific and technique question. If you're very interested, I can ask our tech team, but this is not, I think, important to visualize and download data.
I can put the question on the side also to
Yeah.
have a bit. Yeah. Okay. Okay, so we have also two questions about, so I will highlight this one, but there is a second one. Is it possible to get vectors and raster? And there is also, is it possible to extract the data in ArcGIS Pro as raster or vector?
If I'm not mistaken, yeah, it depends on the data. WEkEO only provide the data that the provider provides. So, for example, with atmosphere data, if the data at the provider side have raster and vectors, you will get able to download them via WEkEO. So I think this is something that depends on the data, but yeah, why not if the data have them?
Okay, thanks. Okay, so this one. Is there a maximum data range for data download?
No. You can put all the if you don't put how do I say, the data will be split maybe in different results, so you will be able to download them one by one, part by part. But yeah, you can download all the data you want. Just be informed that you have a quota of 100 items. So order you made by hour. So just know that. But yeah.
Okay, thanks. Okay. And this question asking, is it possible to download DEM data?
I'm not sure what this
I'm not
data
sure of the,
is.
yeah, I'm not sure either.
Yeah, but in the catalog you can search with keywords, so you can check by entering DEM in the search bar. Maybe you will find the data you want, and if not, And if GM don't show you results, maybe other keyword will. I wish.
Okay, thanks. This question about the Help Center. So when we ask a question to the Help Center, will it be private between the user and Help Center, or will it be available for the public?
No, it's private. It's a chat between us, and nothing will be public.
And if I'm not mistaken, if you have the same type of question coming often, you end up doing an article to help people also.
Yeah, that's right.
Okay.
If this can be useful for others, we will share it, but not your message. Sure.
Okay, thanks. So this question, usually how long does it take to be able to download the data? I guess it depends on the size of the data set.
Yeah, depends on the size. So the first steps is to order data. Like we see in the presentation, this take too much seconds to show you today. But so it depends on the parameters. If you order all the, I don't know, all the temporal extent and geographical extent, this will take too much time. Not too much, but many time. It can be in minutes, like hours. But I invite you to reduce your request to don't, so you don't take too much time. And yeah, it depends on the size and on your connection for sure.
Okay, thanks. Next question. So the land monitoring service in Copernicus offers the possibility to extract data for specific country instead of drawing area as a rectangle. Is that possible now?
No, not on WEkEO. We don't offer this possibility now.
But you can draw not only a rectangle, you can like draw all other sorts of form, if I'm not mistaken, still. Or is it only a rectangle?
Not on WEkEO.
Okay.
Yeah, it's only rectangle and bounding box.
Okay. So yeah, maybe another update to be done on WEkEO.
Yeah.
Next question. Can we inject in situ measurements to increase the detail in the map?
No.
You can't add anything on the view. No.
Yeah, you can add something. No.
Yeah. Okay. Thanks. I think we have time for 2 more questions. Is the data available for Southeast Asian countries?
Yeah, sure. Like you see in the catalog, you can search you can filter the area of the data. And I know that there is many global data, so there is data all over the world. So yeah, Southeast Asian countries. I know there is data, but not for all data sets, sure.
Okay, and we have time for one more question. Can we download data using coordinates?
Yeah, but not for all datasets. I know that some of them don't use bounding box, but coordinates. So yeah, depending on the dataset you're choosing, and if it can be downloaded by coordinates, maybe you can reduce it to a little area if this doesn't filter too much the data. But yeah, depending on the dataset.
Okay, thanks. So yeah, we have to read the information of each product, I guess, to be sure. Yeah, okay, thanks. Yeah. Okay, so that was it for the question. Thanks again, Alexandre, for your demonstration.
Yeah, you're welcome.
And have a nice day. And now we will go to the next presentation, which is the Jupyter Notebook tutorial. So for the participants, you can download them on the website, so don't hesitate to do so if you didn't yet. And yes, so Alexandre, whenever you want, you can start the Jupyter Notebook presentation, and welcome.
Thank you, Gaël. So hello everyone, I'm Alexandre Morin from Noveltis, and I will present to you a use case on a Jupyter Notebook. So let me just share my screen and we'll be ready to go. Okay, so I think you can see my screen. Please tell me if you can't, but
We can see
it
it.
looks like it's working. So, okay, today's topic is the atmosphere. So I've chosen to focus this use case on precipitation indicators, and most importantly, extreme precipitation indicators. So of course, atmosphere, it plays a fundamental role in the regulation of the Earth climate. So precipitations are only one of the key variables in this. There's also temperature, of course. And with the evolution of climate, the precipitation patterns tend to also change. And this is what we're going to analyze in this notebook, comparing current climate simulation to future climate simulations, focusing on extreme precipitations. And of course, you understand why such analyses are important in terms of forecast of future policies to mitigate the potential impacts on the ecosystems and also on human societies and activities. So as I've mentioned on this notebook, we'll be working with Python. And if you're already familiar with Python, you probably already know most of the libraries that we are going to use in this use case. So we'll be using NumPy, which is the one of the most common packages in Python when processing data arrays. Xarray is the library that is commonly used to process scientific data saved in netcdf format. So you will see that the files that we are using are in netcdf format. Matplotlib and Cartopy will be used to draw the different maps and plots in this notebook. And GeoPandas is used to process geospatial data. And also Rasterio is great for processing rasters, but if I'm not mistaken, I don't think we'll be needing this in this notebook. So all those libraries are pre-installed in the WEkEO Lab kernel. So if you're working on the WEkEO Jupyter Hub, you can select this environment and all the libraries I mentioned will be available. So normally you should be able to import them by executing cell without any problem. And now to the data that we're going to use. So as I've mentioned, we are going to use simulated data. So outputs from climate simulation models, which is from this dataset that is available on WEkEO. So you can see description here. So basically, they refer to the CMIP5 simulations that were used to build one of the latest reports from the IPCC, so the Intergovernmental Panel on Climate Change. I think it was, yes, on the fifth report, AR5 in 2014. There have been others more recently, but we have those simulations available on WEkEO, so we are using those. And so basically, in this experiment, in this project, there are many simulation experiments that have been done. Some of them to simulate current climate and some others to simulate future climate under several scenarios. Some with a low emissions of carbon dioxide and some with high emissions of carbon dioxide. So you can visit the dedicated webpage if you want to know even more about those simulations, this project and the associated products. But in our case, in our use case, we will be using two simulations and compare them to one another. So the first simulation that we're going to use is the ensemble experiments for the atmospheric model intercomparison project. So this will be used as a relatively accurate simulation of current climate. As you can see, the period covered is typically 1950 to 2005. And the second simulation that we're going to use as a comparison is a simulation with very high carbon dioxide, which is the representative concentration pathway scenario 8.5. So this is commonly the worst case scenario in terms of climate forcings from the carbon dioxide. And typically, with this model, we simulate future periods, so which can go even beyond 2100. Okay, so back to the notebook. So here are the two temporal coverages of the two experiments. So for current climate, we're using a simulation from 1979 to 2009. And from the RCP 8.5 scenario, we are going from 2006 to 2205, sorry. We still struggle to pronunciate future years. So to retrieve, okay. So here's a brief section on how to retrieve data through the WEkEO Jupyter Notebook. So basically, you need to have this point HDRC file in your home directory when you have registered in WEkEO, and it needs to store your WEkEO credentials. And so executing this cell, it will ask you, if you don't already have this file, it will ask you to enter your credentials, and you'll have this file saved in your home directory, and you will be able to access WEkEO data through Jupyter. So in my case, it's already done. And now you can use the WEkEO API to retrieve data using a request written in the JSON format. So in my case, for example, here are the two requests that I have made to retrieve the data for the two climate simulation. If I open them, this is what I get. So here is the identifier of the data. So this is so the simplified daily data on single levels. You can see that it corresponds here. Here it's for current climate, so I'm using the AMIP experiment. I want to retrieve the precipitation. And those are a model and an ensemble member that I have selected in the WEkEO data viewer. And this is the period that I'm retrieving. So you can see that it's 1979 to 2009. And same thing here. But this time I'm retrieving another scenario, RCP 8.5. Same model, same ensemble member, and of course, different period that goes quite far in the future. And so if you don't want to write this request from scratch, you can go to the data viewer, select the product, enter all the parameters that you want to retrieve. So basically selecting this in the data viewer, and click on show API requests, and just copy, and it will show you the request, and you just have to copy paste it in this file and save it as a JSON. So this is what I did. I copy pasted my request from the WEkEO data viewer. Okay, so this is just a demonstration of how to download the data. So it takes a few minutes, so I will not do it right now, but I have pre-downloaded the two data files that I needed. So as a first exploration, this is the current climate simulation with the precipitation data. So as you can see, this is a 3D dataset with latitude, longitude, and time coordinates. So it covers the whole world. As you can see, the latitudes go from -90 to 90. And same from longitudes, will go from 0 to 360, almost. But in the next section, I'll show some pre-processing that I apply to the data in order for it to be more easy to process with Python. So basically, there are here an extra dimension that we don't want, that only refers to the time bounds and latitude and longitude bounds. So those variables are not useful in analysis. So what I'm doing is I'm just dropping them. And for the precipitation, I have the precipitation flux, which is in a kilogram per square meter per second. And I want to have the total daily precipitation. So I forgot to mention this is the daily data. And so this is per second. I want to have the precipitation per day because this is what we use to compute extreme indicators. So basically, I just multiply this variable by the number of seconds in a day, which is 86,400. And I create this new variable, which is TP for total precipitation. And finally, the last thing I want to do is to convert the time coordinate, which if we look at the sample here, is in a format that is not easily processable with Python. So I'm just converting this to the datetime format. And if I go back after this conversion to my time coordinate, you can see that now it's a different format, which is the most commonly used in Python, and which will help us process the data. So what I propose now is to take just a first look at the precipitation patterns on a random date. So here I've chosen the 1st of October in 2005. And this is, so all those lines are just to set up the map that we have just drawn. So this is just an example of a pattern. You can see that in tropical regions, on this day, we have stronger precipitation, which is quite expected. But now, to the core of the subject, let's take a look at the extreme precipitation indicators. So those indicators, I've chosen 3 of them. So they are from the European Climate Assessment and Dataset Project. And I've chosen 3 of them. You can see, if you want to visit the dedicated page, you will see that there are a lot more, and not only on precipitation. So I will compute the SDII, which is the mean precipitation during wet days, the air 20 millimeters, which is the number per year of very heavy precipitation days, so above 20 millimeters. And the RX1 day is basically the maximum amount of precipitation during a day over a year. So in this cell, I just compute the functions to compute these indicators from the dataset that we have just downloaded. And the next thing I do is that after I've computed each indicator here on the dataset, I compute the mean of each indicator over the 30-year period that we have here. So basically what I'm doing is I'm computing a climatology, which is what we call an average over a long period of time. Here, 30 years is quite common. And what I propose now is to look at those climatology to see if there are patterns in extreme precipitation in current climate. So here is the mean, sorry. Yes, here's an example is the R 20 millimeters. So it's the mean precipitation of days above 20 millimeters per year. So you can see that in current climate, in tropical region, especially here in Southeast Asia, Sometimes there are even more than 50 very heavy days of precipitation per year. And here we are in the 20 or 30 heavy rain days over a year. And also here in the Central Pacific. So this is a pattern that we can expect in this region. And in the next section, we are going to compute this indicator and also the two other ones with the same indicators, but computed on future climate projection to see how precipitation and extreme precipitation patterns should evolve in a worst case scenario in the future. So here I'm opening the second data set, so from the RCP 8.5. Just like with the, to have a comparison with the previous dataset, I will only be selecting 30 years. So here you can see that I'm using the cell method that comes with X-array and selecting only the years from 2129 to 2159. So you can see that the dataset has exactly the same format as the one from before. So just like before, I'm just pre-processing it to remove the bounds variable and so the bounds dimension and those three variables that we don't need that well may produce errors when doing the processing. And I'm also computing the total precipitation here and converting the time coordinate to a datetime format. So here I'm computing the three indicators for our second data set and the climatology, so doing the average over 30 years to compare future climatology with a current climatology. And so this is what we are doing here. You can see that we are drawing a map for the climatology comparison. So we are subtracting the future climatology, well, the past climatology, the current climatology to the future climatology for each indicator. So for each DII, R20 millimeters, and RX 1 day. And this is our result. So this is the difference in mean intensity of precipitation days, so between the two simulations. And you can see that there's a clear pattern where the precipitations tend to be more intense here in tropical latitudes and also in in higher latitudes in temperate regions. But there are also regions where the intensity of precipitation decrease, especially here in Central America, in Australia, or here in North Africa. For the frequency of very heavy rain days, we have quite similar patterns. And for the maximum intensity of precipitation of a daily precipitation in a year, you can see that we have a strong increase in most regions of the world, except here in well, the 15 to 20 to 30 degrees latitudes, North Africa, Central America, and also here, well, in the Southern Atlantic or in Australia. So we can see that this evolution is not, well, spatially homogeneous. So it is consistent, it is relevant to perform some geographical sampling and to study only one region at once. And this is what we do in this last section. I can see that I'm running a little bit out of time, so I'll try to be as exhaustive as possible. But basically, the Intergovernmental Panel on Climate Change has defined several climate regions here, and those are available to download as a geospatial dataset. So basically, this is what we've done here. We've downloaded those reference regions that are all named here with each one has a different label to identify them. And we can, so I've just plotted them to see that we have the same dataset as in this reference. And we can select one of these regions, clip our climatologies, and see and target and focus analysis on a specific region. In our example, I've chosen the Mediterranean. So this is this rectangle here. And you can see that I'm just clipping all my indicators over this region here. And if I plot these indicators and compare each of the 30 years, year to year, between the two climatologies, oh, sorry, I've changed my region at the last moment. Okay. So this is the Mediterranean here. This is the region that we are focusing on. And you can see that in this region, contrary to the most of the patterns that we've seen, we have a strong decrease here in the frequency and intensity of, well, first the extreme rain events, but also in general of the intensity of rainy days. So this should indicate that while there will be less extreme rain events, this region may be subject to, on the contrary, droughts in high CO2 climates. So there are also droughts indicators in this dictionary that I have mentioned. So this should be interesting to study and to add to the indicators library that we have just simulated. But if I look at another region like Southeast Asia, so here you can see that on the contrary, the strength and frequency of heavy rain days is actually a lot stronger in future projections than in current climate simulations. So we're reaching the end of this Jupyter Notebook. So there are the few exercises that you can do at home. I've already mentioned some of them. Computing new indicators that are referred to in the climate assessment project, and also computing for other regions of the world, trying to try other scenarios. So feel free to do that if you do this training on your own. Thank you very much for your attention.
Thank you very much, Alexandre, for the nice tutorial. So we have a few questions for you, so we will go there. Okay. So the first question being, can we also use Julia instead of Python?
I've never heard of Julia, so I don't really know.
Okay, so I didn't heard of it either, but I was wondering, maybe you know. Okay, but yeah, okay. So I put the question on the side to check what it is, but okay. Okay, question about the dataset. What is lat bounds and lone bounds in the datasets?
I'm not exactly sure. I think, sorry, I think those are just technical variables that are inherent to the format of the dataset, probably specifying the maximum and minimum latitude, longitude, I mean the possible coordinates, but they don't contain any scientific data that we are using. So when I work on the dataset, basically those variables generated errors when processing the data. So I don't think so. This is why I had chosen to remove them from the dataset during the pre-processing.
Okay, okay, thanks. Okay, this one, what level of Python skill do you need to effectively use the application ranging from beginner, intermediate, or expert? I think your notebook is well constructed, so even a big beginner could use it.
Well, you can execute it without doing anything, except if you don't have just downloading the data should be yes doable for a beginner. The exercises I have so split the exercise in a beginner and intermediate section. I think for the beginner exercises there is really not that much to do in terms of Python. It's just variables to change, some values to tweak, but this doesn't require any high Python skill. In the intermediate, you probably have to do a bit more because, for example, for computing a new indicator, you have to define a new function and actually do some programming. So this is a little more technical depending on the indicator you choose. But you can use the notebook even if you're a beginner, just out of curiosity, because you don't need to do any more programming to execute the notebook.
Okay, thanks. Okay, so next question. What is the difference in the products from ECMWF and the CMAP precipitation?
I think the ECMWF is merely the platform from which makes the data available. CMIP is, I think, is an entirely different project that just their experiment outputs are available on the platform ECMWF, if I'm correct.
Okay,
I
thanks
think
for the
CMIP is from a very vast consortium of several laboratories.
Okay, thanks for the explanation. And I have the answer about the Julia. So it's a programming language like Jupyter, but yeah. Okay, thanks for this answer. How did you import the data into the Jupyter Notebook?
So I have downloaded it through WEkEO, and so maybe I can just quickly share my screen.
Oh, yeah,
I hope I
of
can.
course.
I hope it is. It can answer the question efficiently. Oops, sorry.
Yeah, maybe it's like, how did you open it to analyze it? I guess.
Yes. So basically, so I've downloaded the data and put it here in the Jupyter lab. So it is something either you download it directly through the notebook and it directly appears in your Jupyter lab. But if you download it, for example, in your file explorer, you can just drag and drop data in this platform. So for just to have the data available here is quite easy. And then I've opened the data using Xarray. So I've imported with the XR alias. And you can see here that my notebook is here and my data is in the data directory. And this is the file that I'm opening in this cell. So basically, I'm writing the file path relative to the position of my notebook. So I just need to go to the data folder and to the netcdf file that I want to open. And using the open dataset function, the data is available. So it takes a few seconds because the file is quite heavy, I think. Yeah, it's almost 400 megabytes, even more for the RCP 8.5 because we have more years. But yes, after a few seconds, the dataset should be opened and ready.
Okay, thanks. And yes, so for the next question that I can answer, so if we can access the Jupyter Notebook you showed here, so it's on the web page of the event. The link will be put once more in the chat, but yeah, you can download the tutorial with the data, and there is also a full video tutorial to go with it if you want to go step by step. Okay, so we have time for one or two more questions. Is the processing run in WEkEO or on your local computer?
Doing everything on the WEkEO Jupyter Hub.
But you still can use the Jupyter Notebook on your own computer if you don't want to run it on WEkEO. So yeah, no worries. You just have to have the right package, I guess. And so I also have this question. I'm not sure if it's for you or for another tutorial, but where is the instruction for the file HDArc creation? I'm not sure I found such a thing in the guideline.
Well, in the notebook, in section 3.2, where we address the HDR file, there is a link to an article from the WEkEO website that describes how to build the file. So
We will
So
put
there
the.
is an article available that is with a link in the notebook. I don't know about which guidelines this user is talking about, though.
I think it was perhaps the guidelines of the tutorial, but if there is an article about it, it's fine. Okay. Okay, so thanks a lot for the. We will stop there for the question. Thanks a lot, Alexandre, for the demonstration.
Thank you very much.
Okay, now we will just take a short break, so a 10-minute break, and we will come back for the rest of the tutorials. Feel free to chat with each other and don't hesitate to look at the poll if you want. And see you in 10. Welcome back, everyone. Now we will go to the next tutorial's presentation, and we will start with the QGIS tutorial. So welcome, Daria. Hi.
Hello, do you hear me?
Yeah, we hear you.
Yeah, great. Well, I'll start sharing my screen first. Do you see my screen?
Yeah, perfect,
Yeah.
Thanks.
Okay, great. So hello everyone, my name is Daria, I'm from Novelties, and today I'm here to show you exercise in QGIS, which is focusing on tracking wildfire smoke transport across Europe. So yeah, for this tutorial, we're going to look at wildfires, and I guess, well, everyone knows, but maybe not, but wildfires are natural or human-caused uncontrollable fires that are spreading through vegetation. And of course, such events, they are very damaging to, well, to resources, to economy, to people's lives. What we are thinking first about wildfires is, of course, damage to like vegetation, to the ground itself. But of course, there's a secondary impact, which is to atmosphere, to the air that we breathe. And that's exactly what we're going to look at today. So for our exercise, we're going to focus on some wildfire events in Europe in 2022. As we all know, that in this year, the summer months, July, August, were particularly hot, like the temperatures were peaking, and that was favorable conditions for wildfire spreading. So I'm gonna quickly show you which WEkEO data was used. So first, of course, it's European air quality reanalysis, so specifically variables to see the impact on the atmosphere. And its two variables are carbon monoxide that we used, and also particulate matter 10 for wildfires. And another one is burnt area product. This one was used just to spot major events, wildfire events. And the last one is R5 land data to have wind direction and data to see how it's spreading. So let's go to QGIS. And as I don't have much time, I'm not gonna go into very like step-by-step procedure. Well, you know that you can access a video of step-by-step procedure and also PDF file. So here I'm gonna just show quickly what we did and what we studied. So first exercise was to find exactly on which wildfire events we're gonna focus. So for that, we downloaded burnt areas for July and August in 2022. So here, I apologize in advance because some of the layers are quite heavy, so it might take some time to like load, but so far so good. And for example, we have two different layers, one for July, one for August. And that's basically the areas that were damaged by different wildfires. And the first step was to have this product. This product is actually global. So next we cut it, like clipped it to the area of only Europe, because we were focusing on European wildfire events. So yeah, from here you won't actually see much difference, but if we zoom out, we would notice that there were areas, burnt areas in other part of the world which were after clipped, but yeah, it could be also quite bulky to process. Then we rescaled, like for example, if you see here, the data, this layer is represented from like 0 to 2012, 212, sorry. And we were more interested in basically making our layer as either it's burned or it's not burned. And for this, we rescaled it to have our layers like this. So yeah, you can see, for example, for white, it's one means it's burned, black it means it's well, a usual ground. And to do so, you can easily use processing toolbox here, maybe I will have it. Yes, raster calculator. It's already doesn't want to really work. Yeah, I'm sorry. It's a bit slow. Okay, we'll give it some time. So the point was to basically do calculations on the raster, like basically saying, okay, I have, yeah, great. Yeah, like I have this layer and I want it to be, no, it's not rescale one, it's before rescaling. Yeah, clipped one, like I want it to be more than one, for example, and it will exactly recalculate the scale to, well, 0 and 1. So like more than 1 is like true and 0 is everything else. I'm gonna, yeah, and then such raster layers, well, still raster layers, they were vectorized and they were also filtered after to obtain only the yeah, the burnt areas we want, and not the whole background. And they also were merged to have overall burnt areas for the whole, well, for the 2 hottest months of 2022, so July, August, like this. And based on that, if you click on this layer and you go to attribute table, can take some time also, you will see basically each feature, each polygon, and you can see well, the values and stuff, and we calculated in the attribute table. Well, yeah, okay, we'll let it load. We calculated area of each polygon to basically see which areas are, well, the biggest, they were impacted the most during the wildfires, and from that we decided to which exact zones to choose to study. Yeah, okay, it's loading. Yeah, it's loading because it has a lot of polygons inside. Like as you see, for example, here we are focused only on Spain, and you see a lot of small features, and it's even more like over the whole Europe. So yeah, we need to wait. But as soon as area was calculated and we decided to focus on some zones, we chose particularly 2. One is in, well, I cannot unzoom, but one is in Gironde region in France, and another one was in Zamora, I think it's pronounced, region in Spain, which we explicitly looking right now. So actually, if you see my cursor, it's a bit strange, but it's this kind of area, and we see there's a big impact. Okay, so yeah, and we decided to focus on these 2 specific dates, specific events, and for dates, we of course we Googled, we found information about what then exactly it happened, and we found out that in Zamora it started on 17th of July, and in Gironde it started 12th of July. Oh, I hope it is. What? Oh no. No, it doesn't respond. Okay. So yeah, we have it. So yeah, 12th and 17th of July, which actually basically means that in the same week we had quite big 2 wildfires, just in different regions, well, in south part of Europe. So yeah, our attribute table finally opened. So here you can see an area, and if you click on area, you also can like sort it by the, like, from biggest to smallest, from smallest to biggest area. And like this, we basically defined our regions, and it's not responding again. Great. So yeah, no, we're gonna wait. And as we know now our dates and the specific, well, position of our events, we can now look at the variables of pollution, air pollution. And for this, it's our next, we're gonna leave this one up. So for that, we had looked at, had a look on carbon monoxide and PM10, PM wildfire variable, which is particulate matter wildfire. And well, for specific dates. So for example, okay, so this one, I honestly am kind of afraid to open this. Okay, great, like this. So here you can see that each raster layer is actually a combination of different bands, and each band stands for hour in July or hour in August. Like here it's for July and here's for August. For example, this is band 417, and if I'm not mistaken, it's yeah, it's around 9 a.m. on July 17th. So yeah, that's not very, could be not very representative at first, and it's also bulky, but yeah, there's also can be some specific pre-processing done to facilitate it, like the whole process. But yeah, it's also possible to work with such data. And here, for example, we have, yeah, so it's 17th, right? As I said, let me just verify quickly. Yes, it's 17th of July. So for Zamora region, for example, we can see it's this one. In this carbon monoxide concentration, you can see here that it's actually well, quite high, right? And if we would choose another time frame, I will try to do that. It will take some time, but we'll still do that. If we choose another time frame, we will see how it evolves, how it was before, because we know for sure that on 17th it was already a fire already had some outbursts, but before and after, we also can see a pattern. And while it's loading, I can tell you that before, it's like 10 hours before, basically, or something like this, there were no peaking carbon monoxide concentration. And after, it was quite fluctuating. So sometimes it was low, sometimes it was high. So it depends on the time of day, depends on day. And that can be explained surely by the fact that wildfires are not, it's not something like, how to say, like predictable, right? So sometimes it's, we think that it's under control and we can, but it's already, it's done, it's finished, you know, and then it like goes again. And then for that, we also looked at PM wildfire, so on particulate matter wildfire, to see how they correlated between the two. And I will show you also, and maybe actually while waiting, I can also show you a little preview like this, because well, QGIS is really taking some time. I hope you can see my like Word document. Maybe if Gail can confirm just very quickly.
Yeah, it's fine.
Okay, great. So yeah, for example, I like this is a file that you also have access to, and you can see that for band for 406, which is like 11 hours before, there were no concentration, no increase in concentration. Then you see with slowly one like hour by one, basically, you see that it's increasing. And yeah, okay, yeah, great, thank you. So yeah, for example, band 408, yeah, you see how it's much low. And for example, way before it's going to be completely nothing. And for example, band 421, we see that there is some leftovers, but it's not peaking. Also, we would notice, you see, for example, here it's again, sorry. We also can see that it's kind of, transferred towards kind of like north, right? So maybe we will see later with a pattern of a wind, if it's true that the wind was blowing this direction. Let's go back to 417 just to have it. Okay. And as I said, we were also looking at particulate matter wildfire one. And this one is the same band, the same time frame. So you can see that, for example, if you can see that PM wildfire variable actually covers bigger distance. And also you can see that it spreads kind of more. And also if you look at different, I will do it basically better like this. if we look at our same bands, we will see that it's more, the concentration is higher, and yeah, as you see, it covers bigger distance and actually stays quite consistent through the time, which can be, of course, linked to the fact that particles, they are heavier, right? Particles of smoke and ash, so they stay longer in the region. Yeah, you see, and well, the carbon monoxide is a gas, so it with mixing of atmosphere and with winds, it transfers much faster. By the way, here you already can see this amazing red pattern here, which actually goes exactly from our second zone that we studied is in Gironde. So yeah, it started in 12th of June, sorry, July, and in 17th of July it was still still there, and you can see exactly how big impact of a small fire, basically. Well, it's not small, but we'll like comparing to, let me show you up. Where is it? Oh, yeah, okay, it will load. So actually on a satellite map, satellite image, you already can see that this area was burned. So I don't, yeah, okay. Now our burned area layer is loading, and you can see it here. So that was the second region we studied. And you see that that's, well, it's still a big region, but comparing to the scale of impact on atmosphere it brings, you can see how actually, well, how massive it is. And if you look at our carbon monoxide, we see that it's kind of less. You see that it's also a little bit different in red, and covers less space. So also I will quickly just show you yeah, how it looked if I would change band, because I don't have much time, so it will just get yeah, it will freeze again. So yeah, again, just before the fire we had well, low concentrations of carbon monoxide. Then it was increasing until, well, quite peaking. Actually two zones, we can see that there are two zones that were not far away from each other over two wildfire events. And the same as with particulate matter variable. As I said, again, you see that it's actually spread on bigger territory, and it's more persistent and stays for longer, seems to. So the last exercise, it's about the wind. So what we wanted to see is exactly look at the pattern of the wind, how it moves, how it spreads the smoke. And this is, yes, this is a 17th, no, this is a 12th. For the 12th of, no, for the 17th, yeah, it's for the 17th of July, I think, the direction. So here in the color, you see these arrows, and in the color, that's the speed of the wind. So the darker it is, the slower it is. So yellow means it's very fast, but yeah, the winds were not particularly strong at that time, but they were still spreading the smoke. And here, yeah, you see the direction of them, like the patterns, quite pretty. And if we overlap them with, for example, this one, I think, yeah, you can see also how it spreads. Where is our zone? That's our zone. Yeah, you see that here, for example, it's brought like this from like what? Towards the west, and then it turns a bit to like north, kinda. And yeah, so like this, of course, this layer is also, it's called a mesh layer. It also has a different time frame, like you see. So each time frame corresponds to 1 day. So that's also important because, for example, this wind data we downloaded was only for 1 day. So we don't have hour by per hour data, but of course there is variables like this on a WEkEO platform. So you can, what you can do as an exercise, you can you can try to repeat the same process, maybe with different wildfire events, like choose other zones, like according to the area, and yeah, download different products to see more like in-depth analysis, like hour by hour, like how wind spreads the smoke, for example. So I guess that's basically it. I don't have much more time anyway. So Yeah, but as I said, yeah, of course it's a bit hectic, but there's step-by-step procedure both in the video and in PDF files. So feel free to check it out and have a more maybe clear picture. So yeah, I hope it was clear enough. Not well. I'm sorry again for the QGIS acting out. And yeah, if you have any questions.
Thanks a lot for the tutorial, Daria. So it was fine with the connection and the slow, no worries. And we have a few questions for you, so we will go to that. Okay, so one of the first question being, are there any predefined libraries available in QGIS software like how we use NumPy in Python?
Yes, there are some because, well, there are some functions in some features of QGIS. They are based on Python language. Even there is even console, like Python console in QGIS, so you kind of even put your function, your code, and see what it's going to give. And I think, yeah, but many functions, yeah, we use specific libraries, and there's also so-called plugins, which is, well, additional tools that you can download and install for your QGIS, and they will allow you to kind of enlarge the available tools, available functions in QGIS, but they are quite often very external. So sometimes they are by QGIS and sometimes they're external. Like, for example, we do have our own plugin, and, well, basically anyone can do a plugin.
Okay, thanks a lot for the explanation. So we'll go to the next question. So we have two questions asking about the CO and PM10 data. So in what format did you download them, and did you use different AIs for the CO and PM10?
So what format is an SCDF file? I assume it's an SCDF file, yes. What format exactly? If it's by time, it was hourly data. So for each hour, there was a concentration for both variables. And if I use different heights, no, I think it was, I need to verify this, but I think it was total column. So yeah, not a specific pressure level.
Okay. Okay, thanks. And then
the next question, yeah, exactly.
Yeah. Okay. Okay, so for this one, it's fine. Can we access Copernicus datasets provided by WEkEO directly from QGIS through online MapRest or WMS, WMTS?
I don't have an answer for that question. I know that there are plugins that allow to access satellite imagery from like Sentinel-2, for example. It's directly from QGIS, but from which source it is, like it's fetching, I don't know. And about exactly Copernicus Marine or WEkEO or climate or whatever, I don't know. Where it could be. I cannot answer that.
Thanks. Okay. One question asking about the version of QGIS you used.
This one is 3.20. I think it's Firenze called. But yeah, supposedly should be more or less the same, especially with the new QGIS versions, I think, because they're up to 20, maybe 3.20, 24, 26 now. I really don't know. But yeah, it's true that if it's older version, there might be some features, functions, but not the same, or they do not work the same.
Okay. Okay, thanks. Okay. One question. So thank you for the wonderful presentation. Can the fire simulation be tracked and visualized over Africa as well?
Yeah, of course. It all just depends on the availability of data, and so yeah, that might happen that we have less data for some specific regions, for example. But the Era 5, it covers globally. This comes with European. It was European air quality analysis, but I think there's global air quality analysis as well. And for burnt areas, it was also global product.
Okay.
So yeah, should be good.
Okay, so it should work for Africa. Okay,
Yep.
thanks. So I have this question. exactly how many bands are available and how are the bands important in autoscopic monitoring analysis. So I'm not sure I understood the question correctly.
Yeah, I'm not sure about autoscopic monitoring analysis as well, but for exactly how many bands, well, here in this in the products we used, the bands, they represent time step, right? Some data available for each time frame. So well, for us it was what, like 24 hours per 30 days, right, in months. So that's how many bands they are. But it also depends on what you download. If you download for 1 day, well, it's going to be 24 bands. But how many bands are important for autoscopic meta analysis? This I'm sorry, I cannot answer.
It's fine. Thanks. Okay. Okay, so and yeah, so this answer for the question we had earlier about the QGIS version.
Okay, well, apparently there's already 34. Well,
yeah. So yeah, plenty of version. Okay. Can we use QGIS, the same GIS, to change NetCDF? I guess it was. Not sure.
To change this, well, what you can do when you have your layers, you can save them separately also. For example, when you imported your layers as a nest CDF with many variables or many time frames, you of course can you can save a specific band separately. So like this, you don't have a big file with, like, I don't know, 200 bands, but you have only one band. So we can kind of say that you can change it, but I don't know, maybe there's something else was meant in this question.
Thanks anyway. So okay, thanks. So I guess we have time for 2 more questions. This one, how to import the database from WEkEO to QGIS. I think you just downloaded the data and called them.
Yeah, well, it depends on which database, I guess. But here person means data, any data we have. But it all depends on the format. So if it's raster or it's vector, but yeah, you just have a layer tab in QGIS and you go there and you add layer, and there are several types of layers, and depending on the format of your data, you add, like, import it specifically. Like, for example, like TXT or CSV file will be added differently than the raster file, so.
Okay, thanks. Okay. So this question, what criteria are used to locate a fire? So I don't know if you did that during the training. I think you just did the data of the fire.
Yeah, well, the criteria for us, like, to spot it was to map burnt areas. So we know exactly that these areas were affected by fire, and then, as I said, we calculated the area of these zones, and like this, I said, okay, this one is quite big, let's study this one. So basically, the criteria is post factum, kinda, the result of a fire.
Yeah, thanks. And so we will go to the last question for today because we are running out of time. Can the simulation be launched in another program? If yes, in which format?
Well, this is a this is a project. Sorry, in QGIS. So if you have QGIS, you just open this project. I think it's also going to be provided to you. If not, I don't know. Maybe you can open it in ArcGIS, for example, because it's also like geographical system, right? So it might work, might not. I don't know. I never tried, and yeah, ArcGIS is also not open source, I think. I mean, it's not available for free. So, but maybe there is a way for our ways.
Okay, thanks. Okay, so that was the last question we had time to do today. Thanks again, Daria, for the nice presentation of the tutorial. And
Thank you.
yes, so we will go to the last tutorial of the day, so the RStudio presentation. And yes, so welcome, Simon.
Hello.
Hi. And yeah, you can start sharing your screen whenever you want.
Yes. Do you see my screen?
Yeah, perfect, thanks.
Okay. So hello everyone. My name is Simon Millet. I'm a scientific engineer at Novartis in France. So you will use the Jupyter Notebook in R to see the extreme drought of 2022 in Europe. So you will also have a closer look of WEkEO's product, their structures, format, variable, and how to plot and explore them. So after exploring the netcdf file, we make a basic plot. Then we do a monthly anomaly maps of temperature. Then the same for annual anomaly maps of precipitation. And finally, we will see the impact of the drought in Porto, especially of air quality. So this training focus on extreme drought of 2022 in Europe. So it was one of the most severe ever recorded, affecting large part of the continent and have a significant impact, environmental impact. It was a combination of exceptional high temperature and insufficient rainfall. And additionally, the drought intensified wildfire that impact particularly in Spain, France, and Portugal. So in this training, we allow to see the evolution of different parameters like precipitation, air temperature, and carbon monoxide over time. So first of all, the Jupyter Notebook must be set up with all necessary libraries. So in this training, we will use the 6 libraries. So there is ggplot2 for creating a graphic, dplyr for manipulating data, rcolorbrowers, it is for palette in color palette in plot, and netcdf4, it is an interface for a netcdf file format. Grid extra, it is to arranging multiple grid plot on a page, and update, it is to use datetime data. So first we load the libraries. If you are using another support and the library are not installed, you can use this command to download the libraries. So now the data. So from WEkEO data, here you can download and search all the necessary data. There is many filters to select the region you are interested. It was shown before. So WEkEO is a European platform, and for this training, we will use ERA5 land monthly average and the CAMS global reanalysis for carbon monoxide. So the files are already downloaded in this training. They are here in the folder data. So you don't have to download it, but if you want to try, it is possible. You need to have your own WEkEO credential, username and password. And if you have not an account, it is possible to create here. Sorry, sorry, I have a problem with up. So now the inputs. So we first work with temperature. So we use monthly temperature netcdf file that is here. We load the netcdf, and you can see very different variables like T2M, that is the temperature, dependent of longitude, latitude, and time. Here you have the 3 dimensions, so the time, the latitude and longitude. And here it is the global attribute to have more information about the dataset. So we load all the variable. it is possible to visualize information of some variable, like the dimension of temperature, that is longitude, latitude, and time, and a value of temperature for one longitude, one latitude, and one time. So here it is the temperature, but we can see it is in Kelvin, not in degrees. So here we convert the temperature in degrees. Here now it is in degrees. It is possible to visualize the time. So here you can see that time is a number, not a date. So to convert the number to a date, we use this function as POSIX. You put the variable time and put the origin. So it is in January 1970. So the origin is noted in the dataset here, that is the second since January 1970. So now it is a date. Here it's just for memory. So now we plot temperature. So first we determine the figure size. Then we create a data frame. So with longitude, latitude, and temperature. Here we use only one time. So it is the index here. It will be the first date of the dataset. Here it is for visualize the data frame. So there is longitude, latitude, and temperature. Here there is none because the temperature was in the sea and here in the land. So there is a value. And here it is for plotting the temperature. So we use the data frame with longitude, latitude, and the temperature. We use the function georaster. Then here it is for color palette. Here general aesthetic, here for title and subtitle. And here it is for position aesthetic option. This one is to adjust the size of the color bar, and here to maintain the proportion between longitude and latitude. So we plot the temperature. So it is the monthly mean of January 1990 of temperature. So we can see that the temperature is lower in the eastern of Europe and in the mountain, especially on the Alps and the Pyrenees here. So now we have seen how to plot a map. What is interesting, it is the temperature during the summer months of 2022 compared to the seasonal normal. So for this part, we create an anomaly maps of temperature. First, we make a monthly average of all the years from 1990 to 2024. So first of all, we create a data frame. So with longitude, latitude, time, and temperature. So here it is a temperature for whole time. Then we create a column with months that correspond of a month. If it is January, it is 1. If it is February, 2, etc. So you can see the data frame, longitude, latitude, time, temperatures, and months. Here it is 1 because it is in January. So the next step, calculate the monthly average. So we put the data frame and we group by longitude, latitude, and months. So for one longitude, one latitude, and 1 month, we calculate the mean temperature. and then we convert the data frame to we convert the variable monthly means to a data frame, and it is possible to visualize the value, the mean temperatures. Here it is a whole Venon because it is in the sea, but you can see for longitude and latitude, you have a value per month. Now we see the anomaly maps. So first we are looking for the time index corresponding to the nearest date in July 2022. So here it is the index. So we create a data frame with longitude, latitude, and the temperature with the index of time. So now we have a value of temperature of July 2022 and monthly means and a monthly mean data frame, but we keep only the month of July here. And here we combine, we do a combination of the two data frame, and we create the difference between the temperature in July 2022 and the mean temperature of July. So here in the data frame, we have longitude, latitude, the temperature on July 2022, the mean temperature of July, and here the difference. And we can plot the map, and we can see almost the part of Europe are in red. So the temperature is well above normal in July 2022, especially in southwest of Europe, so Portugal, Spain, France, Italy. It is possible to see some statistic of temperature. So in the whole map, the average temperature is above 1.5 degrees, the maximum above 5 degrees, and the minimum minus 0.5. So it is possible to try over months, like August, to see the evolution of temperature. So in this part, we will see the annual anomaly maps of precipitation. So we do the same method as seen previously, but annually, because winter precipitation has an impact on summer drought. So first we load the precipitation variable, we create a data frame, and create a mean value, annual mean value, and we combine the two data frame. And the anomaly here, it is not the difference, but it is the anomaly in percentage between the precipitation in 2022 and the annual precipitation. So we can see a large part of the map is in blue. So we see a lack of significant precipitation over part of Europe, except in eastern of Spain here. So lack of precipitation in 2022, and in addition to the high temperature in summer, so aggravate the drought. So now we will see the impact of the drought in Porto. So in 2022, the Portugal faced one of the worst droughts in decade. And this drought create ugly flammable condition. So in this part, we see the evolution of concentration of carbon monoxide from March to October in 2022. So first, we load the data. The coordinate that we want to study is the follow. It is near Porto. So we select the nearest coordinate of the dataset. So it is best coordinate. we find the index of time from March to October, and we create a data frame with the index of longitude, the index and latitude, and between the two index of time. And we can see here the data frame. So there is the date and the concentration of carbon monoxide. And finally, we plot the graph. So here it is a time series. So we use a geom line for carbon monoxide. Here it is for aesthetic option, then it is for aesthetic option. So we can see here the mass fraction of carbon monoxide in air. It is at 1000 hectopascal, so it is near sea level. So we observe three major peaks corresponding to three fires that occur near the city. It is in end of July, the end of August, and in September. And it is clear that the concentration of carbon monoxide during this period is significantly higher than the over time, and affect the air quality for population. So now the training is finished. If you have a question, do not hesitate.
Thanks a lot for the presentation, Simon. It was really interesting to see that. And yeah, we have a few questions for you also. So we'll go to that. The first question being, can we run this air code in Jupyter?
Yes, I use Jupyter because it is more useful to do a presentation with text and code, but it is possible.
So the next question, how much distance can be measured for temperature changes within a single time frame? Is there any specific distance in kilometers or mile? I think it's about the spatial resolution, but I'm not sure.
Yes, I think too, the spatial resolution is 25 kilometers approximately.
Okay.
Yes.
Yeah, I think it answered the question. Thanks.
Yes.
Okay. This question about so we need to work at the point where temperature isn't seen. What do you advise to solve that problem? I think
there is some non value in when you see the data frame, because the points are in the sea, and the data set that we use, it is for land. It is for this there is none of value.
Thanks. Okay. Okay, so we have two questions, or almost kind of the same question. I'd like to know if it's possible to work on RStudio software outside of Jupyter, and what advantages you have by working on Jupyter. And almost the same question under what is the difference in using the Python versus RStudio, and which one is more compatible best?
Yes, so I prefer to use Jupyter for presentation, but RStudio is most useful for programming large code. And the second question, what is the difference between Python vs RStudio? I think the two language is useful to manipulate base data. It is two different code. R is generally used for statistic, but Python or R is good for this data.
Okay, thanks a lot. This question is often there, I think. So lots of people is asking about the difference. Okay, so why did you not use the dwarfs indexes to highlight the dwarfs? I will have trouble pronouncing the word.
Yes, because I didn't know there is a dot in this. Just for this, and I would like to use temperature and precipitation to see other variable.
Okay. Okay, thanks. Okay, another question. Can you please repeat whether carbon monoxide emissions are more in the end of July, August, and September?
Yes, it is against fire because there is many fire near the city, and there is 3 different time of fire. It is for this we see 3 peak.
Excellent. A more technical open question. Can the topography increase the intensity of the heat wave in a particular area?
Yes, the topography can increase. It depends of location, the exact location, but it is possible, yes.
Okay. Okay. Can we use the code to generate a graphic of the variations over time? Because variation of temperature, imagine.
Yes, we see in the presentation the variation of carbon monoxide. So I don't understand really the question, but it is possible to generate time series a graphic representation of temperature, of precipitation too.
Yeah, I think a cell can be added in the tutorial to do that at one point. Yeah. Okay, I think that was the last question concerning the tutorial. Okay, yeah. So thanks again, Simon, for your presentation and the tutorial.
Thank you.
And yes, so thanks again, everyone, for your nice presentation. For the participants, I hope you could learn a little bit more about what WEkEO offers in terms of data. And we hope you have learned something with some of the direct applications we presented to you. Lastly, I just want to take a few minutes of your time to fill in the survey we made for this workshop. So it would be really helpful for us to know what you thought about the session. And yeah, also, before we all go, all of the replays and presentation will be made available. You can already find the replays and the presentation of the first day. And this afternoon or during the next few days, you will receive the recordings of today along with the certificate of participation and also the post-event report with the unanswered question. So thanks again to everyone for joining, and we'll see you next training. Have a nice day. Goodbye.